Hi, I want to take a look at the Tower of Hanoi problem and see if we can solve it. So you may have heard of this problem before, but it was set by some ancient monks, and their task was they needed to move a tower of discs. Here I've just shown 4 discs, and they needed to move them one disc at a time from this peg A that they're sitting on to peg B, and they can use peg C as an intermediate point for some of the discs. And the rule was that larger disc could never sit on top of a smaller disc. So here you see that disc 4 is the largest disc and it's sitting at the bottom. 3 can sit on top of it because it's smaller. 2 can sit on top of 3 and 1 can sit on top of 2. But we could never, for example, have disk 4 sitting on top of disk 1 or 2 or 3. Okay, so that's the rule of the game. So the end condition is that we need to move them all from peg A to peg B. Okay, how are we going to do it? Well, let's pretend that there's a function that we've already got that somehow moves the stack one disk at a time. So here I'm saying move stack, and there's 4 disks, and we want to move them from A to B using C as a spare. So let's pretend this function exists. Let's start it, and this time though, let's just move 3 of the disks. So we move 3 of the disks from A to C using B as a spare. Now, why do we do this? Well, we can see if this magic function works, all I've got to do now is move disk 4 to B, and then I've got this function that can move 3 disks, and I've already moved them from A to C, but I can move them from C to B. So let's see how we do that. So the next step is to move disk 4, and we move it on to B. So I've put move 4 A to B, and now we just need to call our move stack again and move those 3 from C to B using A as the spare. Okay, so this is kind of interesting. Here we've got a top level function here, move stack, and we feed in 4, and then it calls the same move stack with 3. So you can imagine that move stack 3 is going to call move stack 2, and we're going to eventually have move stack 1. So here we are. Let's see how it will look if we get to move stack 1. So here I'm showing that we've only got 2, so we had, now we're calling it with 1. 1 could be on either peg A or peg C, but let's pretend for a moment that we end up like this. And so the last move is we move the 1 peg or the 1 stack from A to B. So here we've written move stack now with n disks. We've generalized it, but we know at some stage we're going to call n-1, and eventually n is going to be 1. And when it's 1 disk, we can just move it straight away. We move that 1 disk from A to B. Otherwise, we call our move stack as it was. So this is the algorithm that we've got. Let's take a look if it works. So let's take a look at our actual code here for this. So we've got, let's set the number of disks to 3. We're going to keep track of the move number. And here we've got move stack, and we're going to pass in n disks, and we're going to move them from A to B, and then using C as the spare. Now here's our end condition. Remember, if n is equal to 1, then we can just move the disk. So we write out to our log, which will come up in this window below, move disk from whatever A is being called to B. Otherwise, we move n-1 disks And our first one was to move from A to C using B. And then once we've done that, we now move the largest disk from A to B. And then finally, we move the stack from C to B. Yep, n-1 of them from C to B. Let's see if this works. Okay, so I'm going to run the code. Yes, there we go. Okay, so let's see what it says. It says move disk 1 from A to B. So that's the little disk. Now we're moving disk 2 from A to C. Okay, so that's fine. And now we move disk 1 from B to C. So now I've got 2 disks on C. So that's kind of, we're done with the first n-1 disk, which moved them. Now we move disk 3 from A to B. So now that's the biggest disk, disk 3, it's there. And then finally, we move the 2 disks now on top of it, but we've got to move from C to A first with the little disk. Then we move the second biggest disk from C to B. And then finally, we move disk 1 from A to B, which is kind of what we said. But the nice thing about this is now, let's rerun this. Instead of having 3 disks, let's do 7 disks. And see if it runs. This is the beauty of computer programs. Now, once it's running, we can do, so it shows us, it's going to take us 127 moves. That's a lot of moves for 7 disks. Let's quickly take a look. Let's suppose we had 10 disks. How many moves do you think? It's going to be a lot. Whew. 1,023. That's a lot of moves. See? Now we've got a lot of disks. That's just 10. The monks had 64 disks to move, and if they moved one every second, it would take millions of years for them to complete. So this is quite beautiful in 16 lines of code here, and we could do in less, I'm sure. We've solved the Tower of Hanoi problem. Okay, I hope you enjoy playing with it.